In this tutorial, I'm going to show you how we can measure any DC voltage with Arduino. As you can see now, it is 12 volts and we are reading 12 volts in serial monitor. I'm going to explain how to calculate different resistors to measure any voltage. Also demonstrate 12 volts, 24 volts, 36 volts and 50 volts. Inside the zener diode, I have at this point I have a resistor, and this is called voltage of R1, and this is voltage of, and selecting R2 at 22 kilo ohm. We can measure with Arduino is 25 volts, 23.5, 23.4 milliampere. So we get 5 kilo ohm resistor. This is the formula to calculate R2 for your application. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. The analog input of Arduino can measure voltages up to 5 volts, but if you input higher voltage, it will damage the chip. For that reason, we need to prepare a small circuit of consisting 2 resistors to bring it down or divide it so we can easily measure. This is for just measuring the DC voltage, but I will have separate video for AC voltage. So we have to reduce and prepare the voltage using voltage divider, which I'm going to explain it next. This video will be very long for people who are learning. If you are just watching my video to get the code and get the value, immediately I'm going to show you the value for, I'm going to give you the resistor value for 12 volts, 36 volts, 50 volts, 100 volts and 250 volts, and then I'm going to show you the formula to calculate for virtually any voltage that you want. This is the input of Arduino. This is analog and the ground. If you want to measure a voltage, you will connect a wire to the ground and you will connect a wire to one of the analog. In this case, I'm going to use analog 0. We can use any of these pins, and this input can accept maximum of 5 volts. If you input higher voltage, you will damage the microcontroller. And to do that, we need to have a voltage divider. When you connect 2 resistors in series and connect them to the power, for example, the positive of this resistor of R2 will be to the positive and the negative will be connected to R1. This is called voltage divider, and the voltage that you get from the input will be divided on R1 and R2, and this is called voltage of R1, and this is voltage of R2 because the voltage are across these resistors. And then to measure the voltage, we will connect from this V out to the analog input as this pin between the 2 resistors. And the wiring will look like this. You have to have also a ground to this point, and this is the input. If we select, I'm going to show you the calculation next, but to measure the maximum of 12 volts, we need to use 5.1 kilo ohm. This is a 1% tolerant resistor, and this is 7.5 kilo ohm. These are the standard values. So with this, you can measure up to 12 volts DC, but to have protection, you need to have a zener diode here between this pin that is connected to Arduino and to ground. This ground you see is connected here. So we need to put a zener diode. The zener diode has a voltage of 5.1 volt. So anything above 5 or 5.1, this will have a breakdown voltage and it will not allow the voltage to go here. For this zener diode, we need a resistor, which already we have it. But if you're sure that you will never have above 12 volts at the input, you don't need it. With R1 at 5.1 kilo ohm and selecting R2 at 22 kilo ohm, the maximum voltage that we can measure with Arduino is 25 volts. With R1 at 5.1 kilo ohm, if we select R2 at 22 kilo ohm, we will be able to measure 36 volts at the input. But if you're worried about the fluctuation, put a 5.1 volt precise zener diode here at the input. With 5.1 kilo ohm for R1, if we select 47 kilo ohm for R2, the maximum voltage will be 50 volts at this input. With 5.1 kilo ohm resistor for R1, if we select 100 kilo ohm for R2, we will be able to measure 100 volts at this input. With selecting 5.1 kilo ohm for R1 and 250 kilo ohm for R2, we can measure up to 250 volts DC with Arduino. Use this formula for whatever voltage you want. Just put here, with considering 5.1 kilo ohm here, you just put Vn, the value that you want to measure, do the calculation and find the nearest value, and then inside the code update this value as well, and you're good to go. Now let me explain the wiring. Here I put here one Zener diode. This is a Zener diode. The model is 1N4733A, but there are different variations of this. You have to find a lower tolerance Zener diode, and here is a data sheet for this 4728 to 58 for this Zener diode, and you can see the tolerance is 5%, which is not good for our application because we are measuring the voltage. Here this NZX5V1B, this has 2% tolerance, and you can search Mouser or DigiKey to find a better Zener diode if you need precise measurement. Beside the Zener diode, I have at this point I have a resistor 5.1 kilo ohm. One pin is at this point, the other pin is at this point, where the Zener diode is parallel with it. The Zener diode has anode and cathode. Cathode is on this side. We have a line, a black line. So you put the Zener diode and cathode on this side. And from the middle where this resistor is, we have another resistor. This is for 12 volts measurement, and it is 7.5 kilo ohm. These resistors are 1% tolerance, so you have to get this. If you get the 5%, or if you get this type of resistors with 5%, you will get huge error. Your input voltage will be connected to this point and to this point. To measure the voltage, we are connecting analog 0 to this point. This green, I've connected it to analog 0 here. And the ground will be connected to this point, which is connected to ground of Arduino. So we are measuring the voltage across this resistor. If you need the wiring diagram for this, it is available as part of my Arduino course at udemy.com. If you want to learn Arduino, I have a bestseller course on Udemy where you can learn Arduino from ground up with hundreds of projects, all course material, library, codes, wiring diagram, everything available in one place. The link for my Arduino course is below this video in the description. Let me now explain the code. We are defining a variable for VCC voltage. It is 5 volts, but I measured it to be 5.01 volt. And if you're using other boards that has 3.3 volts, you have to type it here properly. And then 5100, I did the calculation for R1, and then 7500 for R2. So this will not change based on assumptions that I did in my calculation, but you can change it if you wish. And this is the output voltage, the source voltage that we are expecting, 12 volts. So we know that we do the calculation. The next variable that you have to set is analog pin. Which pin? I'm using analog 0, you can change it. The input resolution is a variable that is holding 2 to the power 10 minus 1. That will be 1024 minus 1. So this is a resolution for majority of Arduino boards, but if you have a board that has different resolution, do the 2 to the power of that. This is a 10-bit. If it is higher, do the calculation and put it here. Otherwise, do not change it. And here inside the loop, this function is giving you the average voltage, and you can do whatever you want with this. These lines are just printing it on the screen. If you need full explanation of the code, you can get it from my Arduino course at udemy.com. With R1 at 5.1 kilo ohm, if we select 7.5 kilo ohm for R2, the maximum voltage that we can measure is 12 volts. And now here is a demonstration. As you can see, the input voltage is 10 volts. It is connected here, and Arduino is connected, constantly blinking at this point and sending data to the serial monitor. And as you can see, we are getting 9.97, 9.98, and that is 10 volts, which is shown here as an input. Because this is not accurate, if I put it in parallel, as soon as I insert it, we have some like 300 or 400 millivolts drop, and that is due to the tolerance and quality of this Zener diode. And now if I increase the voltage, we are reading now, this is now, input is now 12 volts, and it shows incorrect value. And because we have reached at the edge, so 12 is the maximum. Now I can increase the input and the system will be protected, because as you can see here, now 26 volts, and now it shows 12 volts because the calculation for these resistors are such that we will get 5 here and 7 here. So when we get full 5 here, it means we have 12 volts. That's why now this Zener diode is acting properly at higher voltage. So I will reduce it back to 12 volts. Or 11 volts. Now if I remove it, you will be able to read a proper voltage. So that is 11 volts, 10.9, very accurate. And remember also, these resistors are 1%, so the tolerance of these also will have effect on these. Now let me reduce it, and as you can see here, around 7 volts we are reading this value. And now let's measure the actual resistance. Now let's measure these resistance. Let's measure the R1. I'm just putting my probe here across this. It says 5.07, 5070. So, and here let's change it to 507. And let's measure the other one. And it shows 7.45. So 7,450. And I'm uploading now the code. And now here, as you can see, when I corrected the value on the code, it shows 9.07, and here is around the same value. Let me increase the voltage slowly to 12 volts. .5, that's very accurate. So that is 12 volts, and we are reading 12 volts. Let's go to lower, to 3 volts, 3.8, and it is reading very accurately. Selecting R2 at 22 kilo ohm, maximum voltage that we can measure is 25 volts. So let's measure the resistor. It's supposed to be 22 kilo ohm. 22.02, 22,020, and 20. With the new resistor, the range is 25 volts, and we are reading very accurate voltage here. Let me increase the voltage up to 25 volts. Let's go 8. Very good. 10 volts is exactly 10 volts. And here, and 15.8, as you can see, we are reading 15.8. And 23.5, 23.4. That is a 1% deviation from the meter. Let me measure it with my other meter, because let me measure it with this, making sure that we are getting the actual, because this cannot be trusted. So it is 23.5, as you can see. So we are getting 23.5. That's very accurate. Let's go to 25. I want to make sure that I do not exceed, otherwise my Arduino will burn. So we are getting 25 volts here, 24.9, and you can see it is measuring it perfectly. Select R2 as 33 kilo ohm resistor, we will be able to measure 36 volts at the input. 33 kilo ohm resistor, when I measure it, it is 32,830. And now we are going up to 36 volts. As you can see, the input voltage is 26.6, and we are reading very precise voltage here. Let me increase it. And as you can see, we are reading 13.7, and here we are reading 30.8, and that is due to the deviation in this. I've measured this very precisely. Let me go to 36 volts slowly. And here the input is 36 volts, and we are reading 36 volts. Let's go with lower voltage, see if it works. 19.6, as you can see, very accurate. I've updated this value for 47 kilo ohm resistor. I measured it and it was 47,300. And as you can see, the input shows 8 volts. We are reading 8 volts. Let me increase this. $19.8, and you are reading 19.8. And here 26 volts. Let's go to 30, 36. We are reading 36.1, and now I'm increasing the voltage slowly. 39, 39.7, 39.6. My multimeter cannot show it, but as you can see, we are reading now 43 volts. I'm increasing the input voltage. 46. And here the 50 volt is now being measured. And if I connect my multimeter, you will see that the input is 50 volts indeed. I'm going to show you how to calculate this R1 and R2, so you can do the calculation for any other resistor or any other voltage that you want. We have a voltage divider here, as I mentioned. The voltage that goes to Arduino is 5 volts maximum, so we have a parameter or a value here. Then we are choosing a divider current. The current I'm choosing a 1 milliampere would be enough for our application, because Arduino doesn't need any current at the input. It has very high impedance input. And to calculate R1, we do V over I based on Ohm's law, and V is 5 volts and I is 0.01. This is 1 milliampere, so we get 5 kilo ohm resistor. Put 5.1 kilo ohm, 1% resistor. This is a standard value that's available. 5 kilo might be also available, but this is available for sure. So we got R1. To find R2, we have to know that VR1 and VR2, and Vn is equal, this Vn is the sum of VR1 and VR2, the voltage across R1 and across R2. And R2 is equal V over R, this is Ohm's law, so VR2 divided by I, and VR2, if you look at this equation, this VR2 is equal, if you move this on the other side, Vn minus VR1 is VR2. So this voltage, if you subtract 5 volts from the input, that will be VR2 divided by the current, and we get R1 is 5 volts, so we get R2 with this formula. This is the calculation for R2. So this is the formula to calculate R2 for your application. This is an important formula for you. Now in Arduino we will do calculation to find out from these parameters. We will be able to find out the input voltage, and here is how we do the calculation. As I mentioned, Vn is equal VR1 plus VR2, these two voltages, and we know VR1 is 5 volts maximum, and then VR2, this voltage is by Ohm's law, I times R, the current that passes through this, times the resistance, and this I is equal VR1 divided by IR1, because this is in series, the current that goes, so R is still there. I just replace I with VR1 over R1, and then VR1 is 5 volts over R1, and if we do simplification, so it will be 5 multiplied by 1 plus R2 over R1. So this is our formula that I'm going to use inside the code to calculate the input voltage. Thank you for watching. This was how to measure any DC voltage with Arduino, and also how to calculate the resistors. If you learned something and found this useful, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it at the comment section below. I try to answer and reply. If you want to get updates of my upcoming videos, make sure to subscribe. But if you input higher voltage, it will damage the chip. For that reason, we need to prepare a small circuit of consisting 2 resistors to bring it down or divide it, so we can easily measure. This is just for DC. I will have another video how to calculate. This is just for calculating DC voltage. This is for just measuring the DC voltage, but I will have separate video for AC voltage.